Stop talking.
Now we have this set where this
Hello, so you can now continue, madam.
This
You can
lesson.
continue.
Nimekusikia.
Yeah.
So I'm welcoming everybody to this lesson. I want to request that you maintain, you cooperate, maintain discipline, ensure that you maintain discipline throughout the session. So I want us to carry out some revision, and we are going to back to Form 1 topic. We are going to a Form 1 topic, which is minerals and rocks. I want us to go through minerals and rocks. So get your books, your pens ready for this. Back to minerals and rocks. I believe you all have your notebooks there with you. If you have a textbook, a notebook, and of course your exercise book where you wrote these notes. So let's start from the introduction, and maybe let me first of all give you the objectives of the lesson. This is what we've covered before. We just want to remind ourselves on what we covered last year, that is in Form 1. We start by understanding what a mineral is. We define what a rock is. We look at the characteristics of minerals and rocks. Then we get to understand the formation of rocks. Of course, we have the 3 ways through which rocks are formed, but in our case, we focus more on formation of rocks using their mode of formation, whereby we shall look at the formation of igneous rocks, sedimentary rocks, and metamorphic rocks. After that, we go through distribution of rocks throughout the country, we look at what kind of rocks you'll find in the coastal region, western region, central, etc. And of course, lastly, we look at the significance of rocks. So let's get started from the introduction, defining what a mineral is. We know some examples of minerals: gold, diamond, soda ash, and many others. So, naturally, we tend to think that, most of the rocks, most of the minerals are precious because, they are valuable, they have some value in them, but not all the rocks, not all the minerals have value. Like for example, when you look at sand, its value, you cannot compare it with diamond, you cannot compare it with gold. So a mineral, number 1, is an inorganic substance. A mineral is an inorganic substance. It has definite chemical and physical properties. and they occur naturally on the surface of the earth. They physically or naturally occur on the surface of the earth. So it is not an action that is contributed or brought about by human activities. So it is a natural substance that occurs on the surface, on or beneath. It can be on the surface of the earth, it can be beneath the surface of the earth, and it has definite chemical and physical properties. When you go back to your chemistry, when you look at some of the minerals, for example, when you're looking at gold, when you look at diamond, you know, they contain elements and they have distinct chemical and physical properties with them. So using those four characteristics in organic substance that naturally occurs on the surface of the earth with definite chemical and physical properties, either on or beneath the surface of the earth, that gives us the definition of what a mineral is. So therefore, we define a mineral as an inorganic substance with definite chemical and physical properties occurring naturally on or beneath the surface of the earth. There are various characteristics that make up a mineral. There are so many of them. Let us begin with the first characteristic. Number one, minerals have distinct shapes. Take an example of diamond. Take an example of quartz and many other minerals that you know about. All these minerals take different, distinct shapes. And of course, at times, you know, the shapes help us to distinguish one from the other. Apart from shapes, we talk about the degree of hardness. Some minerals, if you just scratch them with your fingernails, you know, because they are soft, because of their texture, you know, it comes out. But there are minerals which are very hard. A good example being diamond. And because of its property being hard, that is why it is used in industries for purposes like drilling, for example. So minerals differ in their degrees of hardness. There are those ones which are very soft, like talc, for example. There are those ones which are very hard, like diamond. So that gives us the second characteristics. The second characteristic. Number three, they vary in their texture. Some are very fine when you feel them with your hand. Some are very rough or coarse. So various minerals vary in their texture. Are we together? You can. Okay, number four, we talk about minerals having different densities. There are those ones which are, you know, heavy. There are those ones which are light in weight. So they also vary in their densities. Apart from densities, there are minerals which are opaque. Some are transparent, some are translucent. Translucent meaning transparent meaning they can allow light to go through them. Opaque meaning they don't allow light to go through them. So that also gives us another characteristic of the minerals. Apart from their being opaque, transparent, and translucent, they also vary in their colors. Gold has its color, diamond has its color, quartz has its color. So all these minerals vary in their colors. And of course, at times the colors help us to identify or distinguish one mineral from the other. Other properties, we talk about minerals having a luster. the surface appearance of a mineral when it reflects light. As a result of that, we have minerals being dull or dark. We have minerals being shiny, depending on how they behave when they respond as light is shown on them. Another characteristic is that minerals have tenacity. Tenacity is the ability of a mineral to withstand tearing or crushing. So as a result of that, we find minerals that are flexible. You know, when pressure is applied on them, you know, they tend to be flexible. You have those ones which are, you know, ductile. You have minerals that tend to crush or break out so easily. So tenacity gives us another characteristic of minerals, and all of them vary in all these characteristics that we are talking about. Another characteristic is cleavage. Some minerals in their formation, you know, they tend to have lines of weakness along them. Like the ones which have, like the igneous rocks, for example, which form, some of them having large crystals, others having very fine crystals. So in their formation, as the rock, as the mineral forms, at times they're those ones which tend to have lines of weakness, like a fault line on them. So such minerals, when it comes to breaking, they tend to break along where they have those lines of weakness. So that is what we refer to as cleavage. Minerals having a tendency to break along certain lines. Another characteristic, there are so many of them, you know that. We have luster. The surface appearance of a mineral when rubbed against a hard surface. Streak is another characteristic that distinguishes the different types of minerals that we have on the surface of the earth. So let me stop there for the characteristics. You can check on more, but I think I've discussed and talked about most of the characteristics that make up different types of minerals. So far, I've defined what a mineral is. I've used the 4 characteristics of minerals to come up with a definition. Minerals are inorganic. Minerals occur on the surface of the earth naturally. Minerals occur either below or on the surface of the earth. And all these minerals, the diamonds, the gold, the quartz, talc, all these minerals have definite physical and chemical composition. And I've said, if you want to understand more about the chemical properties, you get back to your chemistry. You get to understand the properties of different types of minerals. I've talked about the various characteristics that make up the minerals. And of course, another characteristic being, you know, they have different numbers of elements. When you refer to the potassium, the magnesium, oxygen, the elements that make up different minerals. So there are those ones which are made up of, comprises of just one element. There are some minerals which comprise, like for example, bauxite, which comprises of more than one element. So I'm saying, let me stop there for the minerals and their characteristics. Let us move on to rocks. We define what a rock is. Then we go through the formation of rocks by their mode of formation. So rocks, we see rocks everywhere. Those ones who come from the western part of Kenya, those ones who come from the coast, those ones who come from wherever, all the different corners of this nation, at least we've come across these rocks. We've seen them. While wanatoka western, you know, the Kit Mikais, you've seen all those rocks in the granitic toes that you'll find in the western part of Kenya. Those ones who coming from the coast, you've seen the limestone, you know, so many rocks Machakos, you know, the eastern part of Kenya and so many places. So rocks, you know, they make the solid part of the earth. And, you know, the greatest percentage of the surface of the earth, you know, also comprises of rocks. Of course, the dry, we're talking about land, not water. And even water, of course, you know, we've talked about the seam and the soil. Beneath, in the seam layer, you find a lot of rocks there. So rocks, when minerals come together, when they cement together, they harden and form the solid part of the Earth's crust. And that forms the rock. So rocks can be aggregate of mineral particles or just the solid part, minerals that have cemented together to form the solid part of the Earth. So there are three ways through which minerals can form. We can identify formation of rocks by their age. There are those ones which have existed for millions and millions, you know, since the Zinjanthropus and those many other existed from time immemorial. They are young rocks that are formed in the periods, the Mesozoic periods, these various periods that we talk about historically. So they can form by their age. We can identify them by their age. We can identify them by physical and chemical appearance. We can identify them by their mode of formation. And of course, our focus is formation of rocks by their mode of formation. Formation of rocks by their mode of formation, then we have three clusters. We have the igneous rocks, we have the sedimentary rocks, then we have the metamorphic rocks. So I want to start with the formation of igneous rocks. Igneous means volcanic activity. There's magma involved in the process. So either a volcanic eruption occurs, magma rises, reaches the surface of the earth, cools and solidifies, then a rock results. It can also appear that maybe the pressure from beneath is not much strong enough. The rocks cool and the magma cools and solidifies beneath the surface of the earth. And as a result of that, you have rocks that are forming below the surface of the earth. You have rocks that form on the surface of the earth. So that is for igneous rocks. And of course, we can distinguish igneous rocks by their chemical properties, depending on their composition of magma or lava that forms the rock. If you have a lot of, you know, if the magma is acidic, it has a lot of, you know, silica content in it. That is about 65% of silica content. Then you have acidic magma. You have acidic rocks that are acidic forming. If you have a lot of ions and ion oxides and magnesium, then you have basic magma. Then if it falls in between 65 and 45%, that is the intermediate. And if the silica content is below 45%, then you have ultra basic rocks forming. It is good to, you know, get those four categories of igneous rocks. So igneous rocks are the kind of rocks that form when a volcanic eruption occurs, magma cools and solidifies either below the surface of the earth or on the surface of the earth. So we can further classify these igneous rocks into intrusive igneous rocks and extrusive igneous rocks. Intrusive igneous rocks are the type of rocks that form when magma cools and intrusive, internal, means inside. They're the kind of rocks that form when magma cools and solidifies beneath the surface of the earth. So intrusive rocks can either be plutonic or hyperbisal. Plutonic rocks are the ones that form deep below the surface of the earth. When magma cools and solidifies deep beneath you know, where you have, we've talked about the batholiths under internal land forming processes. We've talked about, under volcanicity, we've talked about batholiths, which form deep beneath the surface of the earth. So if magma cools in such depth,
You're not audible.
then you have plutonic rocks forming. It is possible that before ejecting to the surface of the earth, then, you know, slightly below the surface of the earth, that is where the magma cools and solidifies. Then in that case, you have the hyperbasal kind of rocks forming. And I will request you to check and get all those examples of plutonic. For example, we have granite, which is an example of an intrusive rock. Diorite, peridotite, all those examples. And for hyperbasal, we have those examples like the granophyre, for example. We have the porphyry, those kind of rocks that form slightly below the surface of the earth when magma cools and solidifies. So please check for more examples of the kind of rocks that form under plutonic rocks and hyperbasal rocks. Then apart from intrusive igneous rocks, we have extrusive igneous rocks. Extrusive means they form on the surface of the earth when now the magma, as it reaches the surface of the earth and becomes lava, cools and solidifies. I want to believe at least all of us have had a chance to see some of these documentaries that inform us about volcanic eruptions. At least some, we've watched some of these videos in class before. And now that you have access to all these facilities, internet, take some time to watch some of these documentaries. They're very informative. So extrusive igneous rocks are the ones, just as I've said, they form when lava cools and solidifies on the surface of the earth. And we have two categories. We have volcanic ejectors and lava flows. So when an eruption is taking place, in most cases, when a volcano, let's say for example, Mount Nyamlagira was to explode, there was to be a volcanic eruption right now, or Mount Longonot, as much as it's dormant, you know, it is possible that such kind of event can occur in future. When an eruption is occurring on a volcano, the first thing that happens, you know, it is not the lava that ejects, you know, comes out first. You have that cloud of dust and ash, first of all, and gases, you know, all those substances coming out before the magma outpours onto the surface of the earth. So volcanic ejecta are extrusive igneous rocks that form when very light in weight, very fine materials are involved in an eruption. So these substances are thrown up into the atmosphere, but eventually they come back to the surface of the earth and settle around the vent. So the very light ones, when they cool and solidify and compact around the vent on the surface of the earth, they form some rocks. An example of, we know the pumice, the spongy kind of rock because of the substance, the material that form that kind of rock. So that is for the volcanic ejecta. Volcanic ejectors form from these very light, the ash, the dust, the cinders, the very light substances during a volcanic eruption. Apart from the volcanic ejectors, an example we have the tuff. Tuff is a sedimentary rock. Tuff is a sedimentary rock, but of a volcanic origin. And we have the pumice. We are used to the pumice that, you know, what wanatumia in the spas or even at home, you used to rub and kutengeneza miguu. Next, we have lava flow. Lava flows are igneous rocks that form when lava outpours to the surface of the earth, flow And in this case, you have ultra basic lava, which has very limited gases in it, very low silica content in it. So the magma flows for a long distance before cooling and solidification takes place. And a good example is the obsidian. Is a kind of rock that forms from the lava flows. So that gives us, it's not so brief, it gives us a summary of what happens in our first category or classification of rocks, which is igneous rocks. Apart from igneous rocks, we have sedimentary rocks. Okay, apart from igneous rocks, we have sedimentary rocks. Sedimentary rocks are rocks that form from a process that is referred to as sedimentation, whereby materials or crystals are laid down in layers, and after a long period of time, cementation and compaction occurs, which leads to the formation of rocks, which are referred to as sedimentary rocks. So they're formed in layers. They have strata. They have layers that have been laid down for after a long period of time. So in just to maybe break it down, it's sedimentary rocks. They can further be classified into three. We have those ones that are formed through mechanical processes, mechanically formed sedimentary rocks. We have those ones that are formed by chemical processes, chemically formed sedimentary rocks. And we have those ones that are formed from organic processes, organically formed sedimentary rocks. So let's begin with mechanically formed sedimentary rocks and get to see how these types of rocks are formed. And maybe another thing to mention before we completely move out of igneous rocks is, you can be required to break it down in terms of their characteristics. Then one characteristic that stands out under igneous rocks is that they have crystals. Those ones that are forming internally have large crystals. Those ones that form on the surface have fine or smaller crystals. Internal or intrusive igneous rocks have large crystals because the process of cooling and solidification takes quite a long period of time. Because of a lot of heat and pressure beneath, the process of cooling and solidification takes quite some time. So as a result of that, like the granite that result, have very large crystals. But the ones that form on the surface of the earth, that is extrusive igneous rocks, have smaller crystals, because the process of cooling and solidification is quite fast. Rapid. The process of cooling begins rapidly, immediately the lava reaches the surface of the earth. Okay, sedimentary rocks, and in this case, mechanically formed sedimentary rocks. These are rocks that form through physical processes, through mechanical processes. In the formation of mechanically formed sedimentary rocks, you can have erosion taking place, for example. It could be from highland areas, it could be from some given point whereby sediments or crystals are eroded. Erosion can take place by wind, it can be by water, and all those other agents of erosion. So after these particles have been broken down from rocks, they are carried, transportation occurs. So in the first process, we have erosion taking place. After the sediments, after the crystals or the particles have been eroded, they are transported. And the transportation also occurs by the agents of transporting. It can be in water, or by water, or even by wind. So they are carried all the way to the place where deposition occurs. You know, you could be having all these sediments in a river, being transported all the way to the mouth of a river, at the point where the river begins to deposit some of its sediments, and mostly at the very low-lying areas. That is where mostly deposition takes place, because the rate of erosion reduces, because the gradient also reduces. So erosion takes place, transportation of these substances occurs, they are deposited in some given point, either on the riverbed or just on the surface. That process goes on continually. You know, it is a continuous process. Again, sediments are eroded, transported, deposited. So continuously, after a long period of time, you know, these substances that are laid down, these materials that have been eroded and laid down, they compact. And you know, as the layers keep on increasing, one layer after the other continuously, then they compact due to pressure, and a rock results. You have rocks resulting from such kind of a process. So in mechanically formed sedimentary rocks, we have erosion taking place, sediments are transported, they're deposited on water or land, and eventually due to pressure, they start compacting, they cement, and the rock results from that. So these mechanically formed sedimentary rocks, depending on their sizes, you can have those ones that are small, those ones are, you can have them referred to as the arenaceous, the rhodaceous, depending on the sizes of the particles that form. Like for example, if it is the size of sand, if it is the size of a boulder. So depending on their sizes, then you have different types of categories of mechanically formed sedimentary rocks resulting. So check on the examples: rhodaceous, arenaceous. Get at least an example for each and every cluster, or example for each category. So that is mechanically formed sedimentary rocks. Apart from mechanically formed sedimentary rocks, we have chemically formed sedimentary rocks. Okay, chemically formed sedimentary rocks, they are chemical processes. You know, apart from, you know, the very last line that distinguishes or differentiates these three categories, the mechanically formed, chemically formed, and organically formed sedimentary rocks, you know, all of them, there's that aspect of materials being laid down and compacting over a long period of time before they cement to form a rock. So whether it is mechanically by physical mechanical processes, if it is by chemical, you know, they have to be laid down, and after a long period of time, that is when they cement to form the rocks. So in chemically formed sedimentary rocks, you have chemical processes involved. Like for example, the calcium carbonate, you have these minerals that dissolve or react when they're in water. So, and as a result, they are carried in solution form. They react with the weak carbonic acid, they dissolve in water, and they are carried in solution form up to the point where they are laid down, or up to the point where precipitation occurs. And this is not precipitation of the fog, the mist, and the rain, etc. Precipitation, you know, when some mineral is carried in a solution form in water, for example, it gets to a point along, it could be, for example, let's say it is along the river's course. You know, what a river, water is moving from the source to the mouth. from the point of origin to the point where it drains its water to a larger water body. So in the process, the rocks where this water is flowing on can react with the water. So as the reaction takes place, some of these minerals are carried in solution form. I've said, and a good example is calcium carbonate. So it can get to a point where maybe at the end point of this river, then a reaction further occurs. If a reaction further occurs and removes all the moisture and leaves back the sediments at that location, then the process of precipitation occurs. So if these sediments on water or land are laid down over a long period of time, then they compact and you have chemically rocks forming through chemical processes. And depending on the content of the substances, then you can have the siliceous rocks forming if there's some amount of silica in them. You have carbonaceous kind of rocks forming, and very many examples, the evaporites, for example, the chlorides, etc., that form as a result of chemical processes. If it has sodium chloride, then you have the chlorides forming. So depending on the composition of the substances that are evaporated or through a precipitation process, then the crystals that are left behind, depending on their composition, then that is when we further classify them to the various categories, the chlorides, the ironstones, etc. Lastly, we have the organically formed sedimentary rocks. And just as I've said, for these three sedimentary rocks, the one thing you need to just understand from the three categories or classifications of sedimentary rocks is that all of them, whether organic, whether chemical, whether mechanical, layers are involved. Materials are laid down over a long period of time, the cement. So depending whether it is chemical, whether it is physical, whether it is organic, then that is when we have the classification. But the bottom line, or basically, the same process occurs across the formation of these three categories of mechanically formed sedimentary rocks. So in organically formed sedimentary rocks, we have rocks forming due to accumulation of a long period of time of dead plants and animals. So like you have the tropical rainforest, all the trees being cut down, being laid down for a long period of time, decomposing. And as a result of that, you have rocks forming from that process. You have marine creatures in the oceans, in the seas, that die, like the corals. And as they compact and come together, you have rocks resulting from such kind of a process. So organically formed sedimentary rocks are the kind of rocks that form from dead plants and animals. And these can be on land, this can be in water bodies. Over a long period of time, they compact, cement and compact due to pressure, then you have organically formed sedimentary rocks forming. Just the same case as it is for chemically formed sedimentary rocks, depending on the composition. If you have marine creatures, then if you have a lot of limestone in the kind of rock that forms, then you'll have the carbonaceous. If there's a lot of carbon, you have calcareous kind of rocks that form. You have the ferruginous type of rocks forming depending on the elements or substances that dominate the kind of rock that results. So again, I
Siski.
Is it the virus?
Nilikuwa nimemute. Hey, you can come back.
Okay.
Sasa ni wa blue sasa. Oi, adi ana life. Mimi nakujia akiwa
Asante pale.
wow.
Yeah.
What is it?
Yeah. Boy.
Okay.
Yo, nadai. Kisha twende.
Moja amechukua wapi majana? Okay,
Video. Bitch.
Guys,
Teach my
make changes to a channel, then Chuma 2019 apply, apply. To be in these hotels that and then apply, making sure I don't lose subscribers. Alikuwa hapo gari
Gangu mmoja.
Crap. Aha, mama. Hatujamaliza, si mwalimu nimekwambia.
Hadi sijui.
Oya. Ngoja. Simama ngoje.
Hello, madam. Unaweza endelea? Hello? Madam Wanchoke? This thing is now boring.